Hello guys, welcome again to today's class on binary operations. Today we want to discuss binary operation and see what it's all about. To begin, what does binary operation mean? It simply means set of rules which can combine two elements of a non-empty set. Set of rules which can combine two elements of a non-empty set. We have many examples of binary operations. 1. Asterisk. 2. Plus. 3. Times. 4. Minus. 5. Division. 6. Union. 7. Intersection. 8. Composition. 9. etc. So the operations are many depending on the one you remember. Now in this binary operation it has so many properties. Let's discuss some of the properties. 1. Closure property. 2. Commutative property. 3. Associative property. 4. Distributive property. 5. Identity element. 6. Inverse element. Now, what do we mean by closure property? Let's understand it with example. Let us take n to be what? Set of natural numbers. 1, 2, 3, 4, 5, 6, ... Now you pick two numbers from set of natural numbers. Let's say we pick 2 and we pick 3. We combine it with binary operation plus and it's giving you 5. You ask yourself, 2, is it inside or is it a member of set of natural numbers? You say yes. 3, is it a set of natural number? You say yes. 5, is it a set of natural number? You say yes. So that is A, that is 2, 3, and 5 are elements of natural numbers. Then you can now say that 2 and 3 are said to be closed under the operation plus. That is, 2 and 3 can combine to produce another number which is also a set of natural numbers. Remember that natural numbers simply mean all positive number ranging from 1 till what? Infinity. So all positive whole numbers ranging from 1 till infinity. So you now see that 2 and 3 are said to be closed under set of what? Natural numbers. What of me bringing 2 from here, bringing 3 from here, and I put minus? What will it give me? Minus 1. Is minus 1 a member of set of natural number? No. I will say 2 and 3 is not closed under the operation minus. 2 and 3 is not closed under the operation minus. When I check 2 and times 3, what will it give me? 6. Do we have 2 here? Do we have 3 here? Do we have 6 here? You say yes. 2 and 3 is said to be closed under the binary operation times, because when they combine, you will get another number which is what? A set of natural number. So 2 and 3 are said to be closed under the operation times and under the set of what? Natural numbers. Under the operation times and under the set of what? Natural numbers. So you have to specify the operation and the set of natural numbers. That is where they are what? Close. Under the operation times and under the set of natural numbers. This under the operation what? Minus, and under the set of what? Natural numbers. They are not what? Close. Because it doesn't mean that 2 minus 3 cannot be close in other set of numbers. Take for instance, when you are checking set of real numbers. What do we mean by real numbers? Or any number we can think of. Negative, positive, and so on. Any number you can think of. Now, I pick 2, I pick 3. 2 minus 3 will give me minus 1. We say 2, 3, and minus 1 it gave us are elements of real numbers. Because real numbers set any number you can think of. So 2 is a set of real numbers. 3 is a set of real number. Minus 1 is a set of real number. So you say 2 and 3 is said to be close under the binary operation minus and under the set of what? Real numbers. Do you get it? So it doesn't mean that 2 and 3 will not be close in all set of numbers. There are numbers, or there are set of numbers it cannot be close, such as natural numbers. But when you talk about real numbers, or even when you are talking about integers, integers mean all whole numbers, whether negative or positive. That is 0, minus 1, minus 2, dot, dot, dot. Then 1, 2, 3, dot, dot, dot. That is continued. All the whole number, whether positive or negative. Now, 2, 3 equal to minus 1. Is 2 and 3 close under the set of integers? Yes. Because 2 is from here, 3 is from here, minus 1 is also from here. So 2 minus 1, 2, 3 and minus 1 are elements of what? Integer. And because of that, we said that they are close under the set of integers and under the operation minus. So we've been able to note what we mean by close. That is, 2 numbers will combine with the help of a certain operation to produce another number which also fall in that given set of numbers. Okay? See what commutative property mean. When we hear commutative property, let's take for instance 2 plus 3. What will it give you? 5. 3 plus 2. Will it also give you 5? When you add 2 numbers and it gives you a particular answer, and you exchange it and it still gives you a particular number, you exchange it and add them together, it gives you a particular number, the same number. You say that 3 and 2 are said to be commutative under the operation plus. They are said to be commutative under the operation plus. Now let's check again. 2 times 3. What will it give me? 6. 3 times 2. I interchange and I multiply. What will it give me? 6. Did they give me the same answer? Yes. 2 and 3 are said to be commutative under times, under the operation times. Then 4 divided by 2. What will it give me? 2. 2 divided by 4. What will it give me? 1 over 2. You now see that when we come to division, even if we use this 3 cell, 2 divided by 3, it will give me 2 over 3. 3 divided by 2, it will give me 3 over 2. This is 1.5 and this is 0.6 something. You now see that what this gave you and what this gave you are not the same. Then you say division of 2 numbers are not commutative. Division of 2 numbers are not commutative. multiplication of two numbers are commutative, addition of two numbers are commutative, because when you say this plus this and you interchange and add it again, they will give you the same answer. Now 2 minus 3, is it equal to 3 minus 2? The answer is no. This will give me minus 1, whereas 3 minus 2 will give me 1. So we also say subtraction of two numbers are said to not be commutative. That is, subtraction of two numbers are not commutative. Okay? So when you talk about commutative property, it simply means that two numbers, when you multiply or when you add them together and exchange it, add or multiply together, they will give you the same answer. So with this, we can summarize commutative property by saying that addition of two numbers, multiplication of two numbers are said to be commutative. Let's extend it a little. Set A union set B and set A and set B union set A. Will they give you the same answer? Set A is equal to 1, 2, 3. Set B is equal to 4, 5, 1, 3, 5. What is A union B? A union B simply means combine them together without repetition. 1, 2, 3, and 5. What is B union B? B union A means combine the elements in B and A together without repetition. 1, 2, 3, and 5. Are they the same? Yes. We say that addition of numbers, multiplication of numbers, union of two sets, they are said to be commutative. Let's check intersection. A is equal to this and B is equal to this. What is A intersection B? What will it give me? This have 1, this have 1, this have 3, this have 3. 1, 3. Then what is B intersection A? Elements they have in common, still 1 and 3. We can also say that intersection of two sets are said to be commutative. So we have seen the examples of operations that are commutative: plus, times, union, and intersection. Now that takes us to associative property. So if they ask you question, show that these are commutative or show that these are not commutative, please understand what they mean. Commutative property, you add two numbers, you interchange and add again, they have to give you the same answer. Show that these are close under the set of this. Show that these are not close under the set of this. Please understand what they mean. That you are combining two elements under a certain operation to give you a third element that comes from the same set of numbers. Please understand it and apply it accordingly. We go to associative property. Associative property states that bracketing you bracket the last two, it's certain as you bracketing the first two. Associative. So let's take example. A, B2, B3, C4. Let's put it here. Let's know whether they are associative under the operation plus. We say 2 plus 3 plus 4. 2 plus 3 plus 4. Bracket, sort it first. 3 plus 4, 7. 7 plus 2, 9. 2 plus 4, 3, 5. 5 plus this, 9. You now see that addition of numbers are said to be what? Associative. It's also important to note that union of two sets Union of three sets are said to be associative. A union B union C is equals to A union B union C. You bracket this. You bracket this. That means when you unite the or join the elements you have here, then carry it and join here. It is something I'm joining this first before this. It's also important to know that A intersection B intersection C is the same thing as you having A intersection B intersection C. Let's understand. We say let's set A be 1, 2, 3. Set B be equal to 1, 3, 5. Set C to be equal to 2 and 4. We ask ourselves, B intersection C, B intersection C, no set. B intersection C equal to empty. Then A intersection B intersection C. A intersection this, they don't have anything in common. This and this, what do they have in common? Nothing. So A intersection B intersection C will still be what? Empty. This is from set. Now we come to this. A intersection B, what do we have? A intersection B. A intersection B, what do we have? 1 and 3. Then A intersection B intersection C. What are we going to have? This looking for what it has in common with this. Do they have anything in common? No. You put empty set. That means plus union intersection etc are said to be associative. They are said to be associative. Distributive property A plus B plus C, if I bracket the first two, it is the same thing as me having A combined to B plus A combined to C. This is about distributive property. So, in distributive property, let's take A to be 2, B to be 3, and C to be 4. Under the operation plus, 2 plus 3 plus 4, is it equals to 2 plus 3 plus 2 plus 4? Let's check. 3 plus this, 7 plus this, 9. This plus this, 6. This plus this, 5. So this one gave us 9. This one gave us 11. So they are not equal. So here you say that plus is not distributive. I mean 2, 3, 4 are not distributive under the operation plus. 2, 3, 4 are not distributive under the operation plus. That means if you sort out with the operation given to you and what you have here is equal to what you have here, you can comfortably say that they are what? Distributive. That takes us to identity element. Identity element. For identity element, if a number A combines with another number E to give you what? A. You said to be what? Identity element. Where E is said to be what? Identity element. Where E equals to identity element, we say that it obeys this rule. A combined with E to give you A. Where can we get it? A intersection 0, what will it give me? A union 0, what will it give me? A union empty set A. A union A intersection empty set A. A union empty set. A intersection empty set. What do they have in common? You say that it is empty because A have element, empty set do not have element. So what they will have in common is this. In this case, what will be our identity element? This is my identity element. This will be my A and this will be my A. Now in this case, A union this will give me A. This one will be my identity element. This will be the A I wrote here and this will be the A. Then if you say A, any number, any natural number plus 0 will give me what? N. Any natural numbers plus 0 will give me N. Right? This will be my what? E, identity element. This will be my A and this will be my A. A plus E equal to A. We have seen that there are many operations that obey this identity element rule. Intersection of two sets. Intersection of two sets such that A is intersecting with what? Empty what? Element. I mean empty set. A union empty set. N plus 0 equal to N and all have you. These are examples of what? Identity element we talk about. Now when you have something like this, that is what we mean by this. When we go into question solving, you will understand it in full. For inverse element, A combine with A inverse to give you identity element. Have A combined with A inverse and it's giving me identity element. We said that this is what? Inverse element. It obeys inverse element. We will see how to solve questions on this.